Okay, so one object, multiple motions. I have an object here that speeds up from 0 to 20. How do I know? Because this is a velocity time graph, right? Velocity. So the velocity changes from 0 to 20 in 1 second, then the velocity stays the same. Then it slows down and stops. This is the point where velocity becomes 0. And then it changes direction and speeds up to the opposite direction. And then, after another second, it continues with a constant velocity still to the left, to the negative direction. So, one thing we can find is the acceleration. I like having the graphs underneath so you can make so you can see how they are related. So, how do I find the acceleration from a velocity time graph? Slope. So the slope in this graph is rise over run, so 20 over 1. So the slope, the acceleration is 20. Let's have a different color. It's 20. But then the slope becomes 0, so the acceleration in the next second is 0. The object starts slowing down, so we have a negative slope of negative 20. So if this is negative 20 from 2 to 3 seconds, the acceleration is negative 20 meters per second. Then, in the next second, from 3 to 4, it speeds up to the opposite direction, to the negative direction. So, rise over run, the acceleration is now negative 10. And in the last second, the slope becomes 0 again, meaning the velocity stays constant. Now, usually, just because this is not a real case, we add this part of the acceleration with dotted lines. We don't use whole lines. Now, are they going, in the AP exams, are they going to consider it wrong? Well, I hope not. The correct way is the dotted lines, okay? What about position? Again, I do the graph right underneath. So, the position is found by knowing the displacement and the initial position. So the graph, the area under the graphs will give me the displacement. So they need to give me the initial position, where to start from. Usually they will consider it as position 0. So we will start from position 0, here. So the area under the graph for the first second is this triangle, which is half base times height, so it's 1 times 20, half, 10. So after 1 second, my object will be at 10 meters. It will be 10 meters away. Now, how am I going to draw this? Is it a straight line? No. The slope of this graph should show the velocity, and the velocity increases, so the slope should change. So this is a parabola. Now, for the second, the distance traveled, the displacement, the area is 20 meters. So, leaving 10, another 20, it goes to 30. Now, what is this? Well, this will be a straight line because velocity stays the same. So the slope here should be constant. Now, for the third second, the object slows down. Velocity decreases to 0. It does a distance positive because it's still moving on. Just like you slowing down before the traffic light, you still move on. So the car does another 10 meters going to 40, but now the slope should decrease and become 0. So it should be a parabola like that. What about this? Well, this is negative now. The area is negative 50 meters, meaning the car started going backwards. So negative 50 meters means that it goes 50, did I say? I meant 5, sorry. So negative is 5 meters, meaning that it goes to 35. Is it a line? No. So the slope starting from 0 becoming highly like negative, it should be like this. And from 4 to 5 it does 10 meters, which is negative. This is, see, I did the mistake here. Negative 10 meters. Going to 25. Is this a straight line? This is a straight line. So this is how each position changes with time. We can have problems where an object does multiple motions, and we can use the equations. These problems usually have to do with the average velocity, and that will be my next example.